Yes, सूरज आहे आणि कोण आहे? Shall we start? Sankalpa. Good, good. Am I audible now? Sameer. Okay. Good, good. Sankalpa. FYJC. Fine. Chala. Let us start. Sameer is there, Sankalpa is there, Suraj is there. Fine. Let us start with our chapter hydrocarbons, which were we doing. Let me just present. Okay. Is the screen seen? Is it visible? Very good, Suraj. Thank you. Yes. Okay. So far is it clear? Just एक recap घेते. I will just revise. Then we can go ahead. Yeah. This is general. We started with this. First is how to draw the structural formula and electron dot diagram. Okay, Lewis structure ज्याला म्हणता येईल. This is the structural diagram. Then we went to condensed formula. सर्वात basic is molecular formula. Then you have zigzag line. That is, you show this with a zigzag line, right? Then this was homework. I think only a couple of students have done it. बाकीच्यांनी केला नाही. Second time also I gave you all a chance. You all didn't do it. Anyways, then we did was wedge line formula, wedge dot formula. You have a thick solid wedge and a dash wedge. Okay. After that, these lines, they represent the bonds in paper. The thick line tells you bond projecting out and the dotted line tells you bond going behind. Okay. Then you have Fisher projection formula, which is also, these are used to represent the three-dimensional structure. Fisher projection formula tells you about a chiral compound where the carbon is having four different groups. The vertical lines represent bonds which are behind, the horizontal lines represent the bonds which are coming towards us. एवढं आठवतंय सगळ्यांना? Is it clear? Do you all remember this? Okay. Fine. Next, let us go further. What's the problem? Anyways, you are seeing this. Then we went to Newman projection formula. Can anybody tell me what is Newman projection formula? How do you represent the front carbon atom in Newman projection formula? मला कोणी सांगेल का? How do you represent front carbon atom in a Newman projection formula? As a dot. Very good. And what about the behind carbon atom? How is it represented? A circle. बरं, front carbon atom how do you represent a bonds? 3 hydrogen bonds will be seen if you're talking about ethane. So they are coming directly from the dot, right? And what about the ones which are coming from behind? Where do they come from? The behind hydrogen bonds, there are 3 hydrogen bonds in the front carbon atom and 3 hydrogen bonds in the back carbon atom from the circumference. Very true, very true. Good. I just wanted to know. आठवते का? So therefore, this is it. We have seen the ball, the different models also, framework model, then you had ball and stick model also. Yeah, before that you also had a sawhorse projection formula. Acha, how is the Newman projection formula? Is it with respect to the paper? How do you put the Newman projection formula? With respect to the paper, ज्यावेळेला paper असेल त्याला Newman projection formula, is it Newman projection? Sankalpa, Newman projection. Parallel is Fisher's projection. Newman projection formula is it parallel? Parallel कसं असतं? आपण असं समोर बघतो. मग can you, म्हणजे तू आता स्क्रीनला बघतोय तर it is coming from the screen, but is it parallel? Just think about it. Fisher projection formula is parallel. I agree. Parallel म्हणजे पेपरला जसं हे जो आहे तो it is it parallel or it is perpendicular? एक मिनिट. Let me just keep my camera on. Okay. Yeah, perpendicular then you should know this. See, this is my scale is now, right now, is it perpendicular to the screen? Okay. So this is perpendicular to the screen, but the moment this screen, आता मी जेव्हा ती अशी करते ह्या पॉइंटला, this way I am making it, right? So now it is perpendicular to the screen. असं असेल तर parallel to the. मग फिशर प्रोजेक्शन फॉर्म्युला तुम्ही बघता त्यावेळेला it is parallel to the screen असं किंवा असं ठेवलं कसे तरी it is parallel. But the moment when I do it like this, it is coming perpendicular to the screen. मग आता जेव्हा आपण, let me just put it this way. हा, आता ज्या वेळेला फिशर प्रोजेक्शन फॉर्म्युला जर का मला काढायचं असेल, just drawing it. हे जे आहे, this is my Fisher project. This is I'm parallel. म्हणजे आता ही जर पट्टी इमॅजिन केली तर तिला हा असा पॅरलल आहे. पण आता जेव्हा मला सॉहॉर्स न्यूमन प्रोजेक्शन फॉर्म्युला काढायचा आहे, when I want to show it, it will be this is my front carbon atom and then this is my back carbon atom. So I'm putting it this way. म्हणजे आता ही पट्टी अशी आहे. So it is perpendicular. Always remember that. Okay, and mug I'm showing, as you said, that sorry, it has gone inside, it should not go. This is from the back carbon atom and this is from the front carbon. Which are the two different structures which are possible into your Fisher projection, your Newman projection formula? What are the eclipse and staggered? Very good. So have you understood that's perpendicular and parallel? Okay, now tell me staggered and eclipse, correct. Now tell me another this. आता ह्याच्यामध्ये Fisher झाला, Newman projection झाला, आता है Sawhorse projection. How is Sawhorse projection formula? 45 degrees. Yes, it is placed 45 degrees with respect to the sheet of the paper or the screen, whatever it is, the medium. Correct. Very true. At an angle of 45 degrees. Correct. Okay. So lakshat theva. These are the, see here it is making an angle slightly slanting, a long slanting line it can be, wherein you can see show these bonds, staggered and eclipse. Then we went on to see that you have a different model, framework model, ball and stick model, and space filling model. So these are some models by which you can represent. Then we came to classification of organic compounds. You remember organic compounds, they are acyclic. Acyclic means you have open chain, and then you have cyclic. Last time, cyclic are further classified into homocyclic and heterocyclic. Homocyclic, you have alicyclic and aromatic compound. Aromatic compound, you have benzenoid and non-benzenoid aromatic compound. Heterocyclic, you have heterocyclic and non-heterocyclic non-aromatic. We had seen this last time. You all wanted to know what was benzene and benzene ring. There was a lot of But right now we'll go slowly further as we come to benzene compounds, benzenoid aromatic compounds, we'll talk about them. So acyclic or open chain compound, these are known as open chain आहे त्यांना aliphatic compounds पण म्हटलं जातं. Example is propane and propyl alcohol. They have straight chain or they are branch structures. Okay. Then you can have cyclic compounds also. So acyclic, then you have these cyclic compounds. These are compounds in which molecules are formed by joining ring-like structure. Okay, so they are homocyclic when there is only carbon atoms are there. Okay, when there is another atom other than carbon atom, carbon and hydrogen is considered that it is there. You cannot have any compound without hydrogen. With carbon, it has to be there. And all other atoms that are found in organic molecules are called as heteroatoms. So you can see that this is a hetero compound. Then benzene is an hydrocarbon wherein you have only carbon and hydrogen into this. So observe the compound A2C. We had seen this. Identify the compound those contain the ring of carbon atoms only, and identify the compounds in which the ring contains at least one atom other than. And I think you had answered this, that it was B and E. Now coming to alicyclic compound, these are cyclic compounds, similar properties to those of aliphatic compounds. So you have cyclobutane ring. Now here you have cyclopentane ring. In figure 14.7, where is this 14.7? वरती आहे का पुढे आहे मला वाटतं. Sorry, I missed it. पुढे आहे. So here you have, this is cyclobutane. Cyclohexene, this is an alkene, that is, it's a cyclic compound. And then you also have, these are called as benzenoid aromatic compound, ज्याच्यामध्ये benzene ring असते. Benzene ring is this, and there is an OH, so it is an alcohol, but it is not called as alcohol, it is called as phenol. Then this is non-benzenoid aromatic compounds, that is, there is no benzene ring, but they are still aromatic compound. Now aromatic compounds, so you wanted to know what are aromatic compounds. Let us start from here now today. Aromatic is it, I mean, clear so far? Yeah. This was last time we had done. Yeah. So let us go further. Now aromatic compounds have special stability. Means normally, why do these compounds form bonds, or why do they form so many compounds? If you look at noble gases, they do not react. They react very rarely. They are forced to react, then only they react. Otherwise, they do not react. So these compounds have special stability, and always any compound, any reaction ultimately tries to gain some stability, goes to a lower energy state. So these aromatic compounds containing benzene ring are known as benzenoid aromatic compound, while those which do not contain benzene ring are called as non-benzenoid compound. For example, benzene and tropone. So we are now benzene structure is, the structure we had seen it some time back, but I'm still putting it over here, the structure. Benzene structure is this, that is, it is a cyclohexane with alternate double bonds. You had asked me that, yes. So this is normally, this part, this is benzene. Here two benzene rings are joined together, so this is naphthalene. When three benzene rings are joined together, it can be called as anthracene. Okay, so you can have compound like this. Benzene, if you don't feel like putting the bonds, you can put a circle also. It can be. This is what is naphthalene. Two benzene rings joined together. If you have three benzene rings joined together, you can have naphthalene. These are called as homologous. Sorry, not naphthalene, anthracene. Naphthalene is this already here. Anthracene. Anthracene. Cene. Anthracene. Anthracene. Okay. So these are containing benzene ring, and they are aromatic compound. What are aromatic compounds? They contain aromatic compounds with special stability. These compounds contain benzene ring. Okay. Now coming to figure 14.8, this is 14.7, illustrates some heterocyclic compound. Now you can see that here you have ring structure, but other than carbon, you also have oxygen. So it is called as furan. When you have sulfur in it, it is called as thiophene. Thia means sulfur. Pyridine, when you have nitrogen, it is a six-membered ring system with all, just like benzene. Remove this nitrogen and you will get benzene structure. But instead of one of the carbon of benzene, you have nitrogen. Just a moment. Give me 2 minutes. I'm just coming. सोसायटीचं बिल आहे. Yeah, sorry. Okay. Okay. Coming back to our, yeah. Now, these are furan, I said thiophene. Any compound which contains sulfur in it is called as thio. Pyridine. Then you have five-membered ring system. See, when it is five-membered ring system with oxygen in it, it is called as furan. When it is sulfur, it is called as thiophene. When it is nitrogen, it is called as pyrrole. These are five-membered non-benzenoid system. They are heterocyclic aromatic system, which is having, when it is oxygen, it is called as furan. When it is sulfur, it is called as thiophene. And when it is nitrogen, it is called as pyrrole. But a six-membered system with a nitrogen, it is called as pyridine. Now, one question it will be there on your minds. तिकडे तुम्ही structure कडे बघाल, तर you can see that here nitrogen. एक मिनिट. You can see that इथे nitrogen आहे, and here also you have nitrogen, but you have hydrogen with nitrogen. So why is it so? But you know nitrogen valency is 3. So here it is getting completed. With nitrogen already is over here, it is like this. You can see that. So nitrogen से 3 bonds, म्हणजे it is, his valency is complete. But इकडे बघाल तर you can see that nitrogen is having only 2 bonds over here. So the third valency gets completed with hydrogen. Yeah, it has sulfur la garaz nahi hai. It is even same way, because oxygen and sulfur belong to the same groups in the periodic table, so they are satisfied with those two valencies. So here you don't have any hydrogen. Are you following? When you're looking at the structures, if you have any question in your doubts, in your mind, so if you have any doubts, you can always ask me. So is it clear that why that hydrogen is yeah, but why it has benzene? But why it has no, Suraj? Yes, it is non-benzenoid. Okay, fine. Why carbon is non-benzenoid aromatic? Why? What is it? Why carbon is not non-benzenoid aromatic? Why carbon is not non-benzenoid aromatic? नहीं कळलं मला. See figure in 14.7. Okay, let me just see figure. Okay, wait. Slowly, let me see your questions, because when I was teaching, you all were writing. Why is carbon is non-benzene? Why is carbon is non-benzene? Which one you're talking? 14.7. Where is carbon? This you're talking about? Is it tropone structure? और सायक्लोब्युटेन, विच स्ट्रक्चर आहे 14.7 मध्ये कुठचं स्ट्रक्चर बद्दल तुम्ही बोलताय?
Ma'am, I guess he's talking about phenol and
Phenol
tropone.
and tropone. One moment. Here, phenol is having a benzene system. This is benzene ring system. Propone मध्ये you can see that this is not benzene. It is a non-benzenoid structure. See, benzene is having 6 membered. Here you count how many carbon atoms are there. 1. Okay, this is 1 carbon atom. This is 2 carbon atom. This is 3 carbon atom. This is 4th. This is 5th. This is 6th. And this is 7 carbon atom. 7 carbon atom is not a benzene system. Benzene is always having 6 carbon atom. The basic unit of benzene is with 6 carbon atom. So here you can see this is benzene. Here you can see that there are how many carbon atom? 1, 2, 3, 4, 5 and 6. So the first unit is the benzenes. जसं तुमचं हायड्रोकार्बन्स मध्ये मिथेन जर का पहिलं युनिट घेतलं, then you add another CH2 to it, then you get ethane, then another then you when you add another CH2 you get propane. So similarly, now yeah, he is talking about, see how I see there are 3 alternate bonds. Fine, alternate bonds also you are seeing it. Then I'm going back to structure. Are these alternate bonds? When you see this is, sorry, this is alternate one. Okay, one double bond, then you have one single bond. Again double bond, then you have single bond. Again double bond, you have single bond. After this, there should be double bond in the ring. Is there any double bond in the ring? No, the double bond is outside the ring. And then again you have a single bond. So this is nowhere coming, I mean, like your benzene structure. Okay, benzene structure, you can see that here. Here this is also, you can say benzene, but it is having an OH to it. See here one double bond. So this is double bond, this is single bond, this is double bond, this is single bond, double, and then again single, again go back, you have double. This is called as alternate double and single bond. Are you following it? Is phenol a non-benzenoid aromatic compound? No, phenol comes under this aromatic compounds only. It is a benzenoid aromatic compound because basic unit is benzene, you know. So phenol मध्ये benzene आहे, benzeneच्या carbonला you have an OH group. So it is a aromatic compound. Your book, it is given as non-benzenoid. Phenol ला दिलाय non-benzenoid structure. How come? कुठे दिलाय? Which book? Let me just check it. Okay, इथे दिलाय benzenoid aromatic compounds. You have phenol over here. Which book are you talking about? It is given as non-benzenoid aromatic compound. Yes, Sankalpa. Which book? I'm talking about this book which we are doing right now. Here. It's a. Anyways, let us go further. See, classification based on functional group. Now, you have the same book, but the figure is little different. This is the same book. It is your. How can it be? This is it. Anyway, we'll talk about that later. जसं येईल तसं आपण पुढे बघूया. Let just maybe you can, yeah, we can go ahead. That phenol is given as non-benzenoid compound. Anyways, you put me a screenshot on my apna homework na class. You just put there a screenshot. I would like to see what book you're talking about. Okay. Anyways, coming back over here, that consider the following reaction. Now let us have a reaction. Here you have CH3, CH2, CH2OH. This is an alcohol series. You have not done, we'll be doing nomenclature after this. In this, you are replacing this H by this, where is my highlighter? Yeah, here you have, this is getting replaced by Na, okay, ONA. So you can see CH3, CH2, CH2, ONA plus H2. That is the balancing of the reaction. You know that in 7th or 8th standard you must have done is hydrogen is released and H is replaced by Na. Okay. Now coming back to Yeah, compare the structure of the substrate propanol. This structure is the propanol structure, okay, with that of the product sodium propoxide. ह्याला म्हणतात sodium propoxide. This is sodium which is with now combined with propanol, H is in, so this is sodium propoxide. Which part of the substrate, the carbon skeleton or the OH group has undergone a change during the reaction? आता ह्याच्यामध्ये the question is which has gone undergone a change, whether the carbon skeleton has undergone a change or your OH only has undergone a change. Can you tell me? Now in that reaction आता आपण बघितली, what was the reaction? It was a reaction between, yeah, so what, which part of the, have you followed it? Only the functional group. Very good. Only the functional group. Functional group म्हणजे OH. You already know that, so you have said that functional group. But right now they just want to bring us our attention to that functional group. So correct. OH here is the functional group. It has undergone a change. Very correct. Now coming to the next this. So a part of an organic molecule which undergoes a change as a result of reaction is called as the functional group. Very correct, which is continuously changing. So that, and because of which you the compound gets its properties, that is called as a functional group. If you compare a hydrocarbon, say for example only carbon and hydrogen is there, say for example I'm just writing CH3 and CH3. This is ethane. And now the same structure, I'm just putting it as CH3 and I'm changing this CH2 to OH. What have I done? इकडे जो एक H होता, that I have replaced with OH. This is called as ethanol. And this is called as ethane. So we have replaced one hydrogen with OH group. So the properties of this compound and this compound are totally different. So therefore now the hydrocarbon has changed into an alcohol. The functional group will be alcohol. We are going to learn more about that. In the above illustration, OH is the functional group present in propanol. Inspection of structures of various organic compounds tell us that there are a large variety of functional groups present in them. The second method of classification of organic compound is based on nature of functional group present. The resulting individual class is called as the family. Okay, so based on that, you can also have a family named after the constituent functional group. For example, a family of alcohol, a family of halogen derivatives, something like that. Table 4.3 shows some common functional groups with their names, bond structures, and examples. We'll see those later on as we, this is the table 4.3. We'll be looking at it properly with different functional family or the functional groups. Okay, structure, what is the structure of the functional group, and then you will be seeing some examples. Right. So first, most important is the functional group, and then you can have a family of the functional group. Is it clear so far? Must be only the functional group. Okay, fine. So far, okay. Let me go further. So from the representation of the structure, when we started with this chapter, we talked about how to represent an organic molecule using different methods. See the condensed formula, molecular formula सुरुवातीपासून which you are aware of, then the condensed structure, the structural formula, condensed structural formula, Fisher projection, that is a projection form. Then how to represent three-dimensional structures, that is, of course, before that Lewis dot structure, then we had wedge dot structure, then we had Fisher projection, Newman projection, Sawhorse projection. After that, you can also represent something like with a ball and stick model or a network kind of a model. Then we came now to talk about classification of organic compound. Organic compounds can be classified as your straight chain and cyclic. Then you have cyclic compounds can be further classified into as you have alicyclic and aromatic compounds. Aromatic can be non-benzenoid aromatic, and yeah, of course, heterocyclic compounds are there. Then you have cyclic compounds, homocyclic and heterocyclic. Out of that, homocyclic can be further classified as aromatic and compounds non-aromatic. Aromatic will be benzenoid aromatic and non-benzene. So various ways of classification we saw. Then we are now talking about the functional group. Functional group is that part of the molecule which confers the property to that molecule. Okay, so we'll be talking about all those things. Further, now come to this is another thing which is very important. A family of functional group in turn comprises different homologous series. Homologous series means they differ by a small unit, a series of compounds, the same family in which each member has the same type of carbon skeleton and functional group and differs from the next member by a constant difference of one methylene group in its molecule, and the structural formula is called as homologous series. Okay, for example, now if I want to represent one series, say for example, this is my first CH4. Okay, after that I add CH3, CH3 and CH2. If you calculate CH3, if I add this, you will understand that I have added another CH2 group into it. Okay. Next is you can see that propane, CH3, CH2, and further CH3. Okay, here you can see that I'm adding CH2. Another this CH3, next one, CH2, CH2, and CH3. So every time you can see that I'm adding. So this is a homologous series, a family. It again is a family of functional group. What is a functional group? It is a alkane series, that is hydrocarbon. In this, I am adding. It differs. This is one homologous series. It is a series of compounds of the same family in which each member has the same type of carbon skeleton. You can see that here the carbon skeleton is same, and it differs with the from the next member by CH2. That is one methylene unit. So it is differing by that unit. Say for example, let us take another example. Say for example, we go with CH3 OH. Okay, this is my first OH म्हटल्यावर तुमच्या लक्षात आलं असेल I'm using alcohol series. Another CH3, CH2, OH. What have I added? Another CH2. Next CH3, CH2, CH2, OH. So you can see another. So this is another homologous series. A family is alcohol, and each member is differing from the next by CH2 unit. Okay. So this is something which you should remember. You should know that. They can ask you a definition of what is a homologous series. A short note can also be asked on this. So it is a family of functional group. It comprises of different, a series of compounds, the same family in which each member has the same type of carbon skeleton and functional group, and it differs from the next member by a constant unit of one methylene group in its molecule and structural formula. So this is something is called as homologs. An individual member of homologous series is called as homolog. When methane will be one homolog, ethane will be another homolog. All members or homologs of each series are represented by the same general formula. Does anybody know how the alkanes are represented? What is the general formula for alkanes? Anybody knows? Alkenes, तुम्ही केलंय ना? I think you have done it. Yeah, CnH2n. CnH2n. For alkanes, Sankalpa, is it CnH2n for alkanes? Say for example, methane. Here it is. calculate, is it CnH2n? If C is equal to 1, H is equal to 2 into 1. So what should it be? Is it CnH2n? Hey, this, it is, H should be capitals. Arey, Atharva is to, again you are giving me something else. But you can calculate over here, na? Say for example, if I am putting in next homologue, that is ethane, C2H6. आता C2H6 count करा बरं. Put your N as 2 and then count. Is it minus? Atharva, चुकून झालंय का? Are you really saying that it is minus? This is correct. CnH2n plus 2. Alkanes are represented by CnH sukun. Okay, very good. So alkanes are represented by CnH2n plus 2. Okay, sukun झालंय. Oh, agreed. So this is it. And then if you have, you must have done in earlier this also. Alkenes are also there. Alkenes मध्ये CnH2n जो तुम्ही मला सांग. Yeah, alkenes are CN. And then what about alkynes? जे उत्तर आपल्याला अथर्वनी दिलं होतं आधी. CnH2n minus 2 is alkynes. Very correct. Good. Okay. So you are representing that the homologous series of alkane has a formula CnH2n plus 2. Alkenes will have the other CnH2n, and CnH2n will be shown by alkynes. Okay. So the member of a particular homologous series possesses similar chemical properties which those vary gradually in their the members of a particular homologous series possess similar chemical properties. Those vary nahi hai, it should be vary means change. It should be it should be vary, vary. Hey, vary nahi hai. Vary, I mean vary is change, so they change gradually in their physical properties. Namely melting point, boiling point, density. हे सगळं स्लो चेंज होतो जेव्हा एखाद्या होमोलॉगस सिरीज मध्ये यू गो फ्रॉम वन मेंबर टू दी अदर मेंबर. There is a gradual change in their physical properties, that is melting point, boiling point, density, solubility, etc. So table 14.4 illustrates this with the help of homologous series of straight chain aldehydes having a general formula. We'll see that. Okay, we'll go there. Now, do you know that aliphatic compounds are named so because of their attraction towards fats? Okay, aliphatic. And aromatic compounds are named so because some of these compounds possessed aroma. Aroma, you know, is smell. So some names were initially given based on sometimes something they found out, but later on need not be that it is true for all the compounds. Aromatic compounds are not so perfumery. Some of them are, yes, some aromatic compounds, some ketones and all can be used in perfumery and all. So people thought that all these compounds had a beautiful smell, so they were called as aromatic compounds. Aliphatic compounds are named so because of their attraction towards the fat. So this is some additional information given to you. But have you understood what is a homologous series? Shall we go further? We'll talk about the functional group. Okay, yes. Now coming to functional groups in organic compound. So here you are. First is halides. Halogen ज्याच्यामध्ये त्यांना halides म्हणतात. You represent it as X. Okay, say for example, I'm just putting it over here. I have this as CH4 is my methane. But if I change this, मगाशी मी alcohol ला कसं केलं? So I am putting it as CH3X. This is, I am getting one halide. Which is here you have this X can be, of course, X can be इथे द्यायला पाहिजे. X is equal to Cl bracket मध्ये टाकते Br I or F म्हणजे ह्यातलं काही असेल तर. So here I have put in X is there. Here you are putting CH3Br. So X is now Br. So it is methyl bromide. जर तुम्ही IUPAC name बघायला गेलात तर it is bromomethane. We'll talk about that later as we go on further. So X is the so this becomes a halogen series. If you are supposing representing it, say for example, I can write it as CH3 X first. मग bromine घ्या, chlorine घ्या, काहीही घ्या. Then I am putting it CH3 CH2 X. This is my ethyl bromide. Supposing if this is Br, okay, CH3 किंवा chloride असेल तर methyl chloride, ethyl chloride, iodine असेल तर iodide असं त्याचं नाव होईल, but that is the common name. CH2, CH2 and X. So you can see that now this is a family of halogens and each next homologue is differing from the earlier member by CH2 unit. So you get this one and it forms, so here the functional group is X, that is the halogens. So this is a halide series. The family is the halogen family. Next is, are you following this? So shall I go to the next one? Let me go to the next one. Coming to cyanide. Now instead of X, you can put it as, I can put this as, त्यांनी cyanide split करून दाखवले, त्याच्याऐवजी I can put it as CN असं. नुसतं CN. म्हणजे आता X होता त्याच्याऐवजी now I can have CH3CN. Okay. Then I can have CH3CH2 CN. I can have CH3 CH2 CH2 CN. See, my next homologue is differing by this unit. Okay. So CH3CN, this is methyl cyanide or acetonitrile. It is called as methyl cyanide or acetonitrile. Fine. Next you have isocyanide. म्हणजे मगाशी कसं CN होता त्याच्याऐवजी you have NC. Okay, that is isocyanide. So same family you can have isocyanide family. Very. Then you have nitro group. म्हणजे आता इथे CH3X होतं त्याच्याऐवजी CH3NO2, C2H5NO2 असं पुढे पुढे you can have. Then you have OH. So instead of X you can have OH. That is the alcohol family. Now AR is nothing but aromatic compound. जसं बेन्झीनचं जे आहे तर ते मगाशी आपण फिनॉलचं स्ट्रक्चर बघितलं. So this is it. This unit is called as हे बेन्झीन वाला alternate double bond वाला. दोन्ही स्ट्रक्चर माझे करेक्ट आहेत हे also, पण मला समजा हे जर नको असेल तर I can put it as a circle in the ring. Then it also shows. This unit is called as AR. त्याला म्हटलं जातं AR आणि मग त्याला पुढे जर मी OH लावला तर it becomes a phenol. This the functional group is the phenolic functional group. त्याला म्हटलं जातं. Fine. Then next is you have amines, wherein you can see that here instead of Br you have NH2. These are called as amines. Amino acids तुम्ही केलं असेल. Our body is made up of amino acid. Proteins are in you having amino acids. Amino acid किंवा amino acid कसंही तुम्ही म्हणा. So त्याच्यामधला amines is there. Then methyl amine. This is having NH2 CH3. So methylamine, ethylamine, propylamine. So all those are going to be. Next you have that is tertiary and then now you have this is a primary amine. You can have a secondary amine, that is nitrogen is attached to 2 carbon atom. So it is secondary amine. Tertiary amine is nitrogen is attached to 3 carbon atom. You can see the hydrogen number from nitrogen is differing. When it is a methyl amine, you have 2 hydrogen atom. When it is secondary amine, you have 1 hydrogen atom. When it is tertiary amine, there is no hydrogen atom. Then you have ether family. Ether family is between two. This you have oxygen. Okay. Now this is dimethyl ether. You can have add another CH2 group. You can have the next member. So COC is ethers. Then you have aldehydes. Aldehyde is CHO. So here the structure of CHO is with a double bond to carbon. So CHO. This is acetaldehyde, the first member. Then you remove this H and you put in over here R. R is nothing but the alkyl groups. Alkyl groups means the carbon hydrogen group. So you can see that if there is no H but still that CO is there, then this becomes, here you have CO, here also you have CO, but you don't have H, then you have the ketone family. Then you have carboxylic family wherein you have COOH. Then now remove this H and you put in over here, instead of this H, you can put in over here another R. R means that is you have some other group, not H, then you call it as ester family. If you put NH2, you remove this O and you put NH2. NH2 was seen in amines. So if you put NH2 over here, you can get amides. Again, just like primary amine, secondary amine, you also have secondary amide, you have tertiary amide. Nitrogen when attached to two carbon atom, it is called as tertiary amide, and nitrogen should have a carbonyl group. CONH is a secondary amide, tertiary amide also. Then you have acid anhydride, that is you remember this was something as ester group here. So instead of that, remove this and put another CO group, you get acid anhydride. If you add chloride over here, then you get acid chloride. You have sulfonic acid, then you have wherein SO3H is the functional group, just like you have acids over here, same thing, but here you have sulfonic acid. Then you have alkenes, alkynes, and alkanes, there is no functional group because there is only, the straight chain first basic hydrocarbons. Okay, have you understood so much? I know it is a big family. You will have to go through it here. I'm just telling you, but you will have to learn this to begin with. लक्षात ठेवायला तुम्हाला थोडं हे करायला पाहिजे पाठ, म्हणजे त्या इथे मला म्हणजे त्या फॅमिलीज ज्या आहेत त्या एकदा जाणून घ्यायला पाहिजे, अँड यू विल हॅव टू राईट इट डाऊन a couple of times and then just close your book and try to recollect whether तुम्हाला जमतंय का, कळतंय का. Okay, but is it clear to you? Are you following it? Sure, na? Yeah. Go to the functional groups and just have it. Once we are done with it, see, now your college is not yet started. You have an advantage since you're coming here for this lectures, and also it's a good thing that you have already started. म्हणजे कॉलेजमध्ये शिकवलं तुम्हाला सोपं जाईल, पण आता वेळ आहे हा तो जरा कारणी लावा. That whatever we do, go read it, try to make your own notes also, त्याच्यातले पॉइंट्स काढून, आणि काही गोष्टी मात्र तुम्हाला थोड्या हे करायला लागतील, पाठ करायला लागतील, लक्षात ठेवा. आता फंक्शनल ग्रुप्स वगैरे सुरुवातीला नवीन आहे, एकदा लक्षात आलंय की तुम्हाला ते स्वतःहून यायला लागतील. Then you don't have to memorize, but here now you will have to look at it. A few functional group you must be knowing, but here there are about 20 to 23 functional groups which you will have to write them down. Okay, then only. Now say for example they have given us a problem. Alkanes constitute a homologous series of straight chain saturated hydrocarbon, that is methane, ethane, propane, butane. Write down the structural formula of the first 5 homologues of this series. Write their molecular formulae and deduce the general formula of such homologous series. So this can be a question which can be a 5 marks question. I do not know maximum marks how many are given, but 2 or 3 marks question also they can ask you. The first 5 homologues are generated by adding CH2 at a time, starting with the first homologue methane. मगाशी आपण बघितलं methane मध्ये CH2 add केलं तर you get the second homologue ज्याला ethane म्हणतात. So CH4 plus CH2 gives you C2H6, that is ethane. Again add another homologue, third homologue, which is called as propane. Then you add another CH2, you get next homologue, that is butane. Add another CH2, you get the next homologue, that is pentane. So by count, and then from that you can find out the chemical, what kind of general formula alkenes have. So that I just now asked and you all gave me the right answer, because by counting the carbon and hydrogen atoms in the 5 homologues, we get their molecular formula. What is, so you arrive at the molecular formula, which is nothing but CnH2n plus 2. कारण तुम्ही बघितलं, the number of hydrogens and the number of carbon, they are related to each other by CnH2n plus 2. Okay, so that is how they have explained it. Magashi जे आपण बघितलं, we checked it before coming over here. Okay, so that was it. Next is write down the structural formula of a third of A. One is the third higher and B the second lower homologue of CH. When you are given CH3, CH2, COOH. Okay, you are supposed to be writing the third higher homologue of this and the second lower homologue of this. Can you write it down in and can you write it down and let us see whether you are right or not? Just check it out. येईल जमेल तुम्हाला त्यांनी आपल्याला स्ट्रक्चर दिलाय एक मिनिट हा इट इज CH3 CH2 COOH. Now you have to write down the structure of the third higher and the second lower homologue. What is it? This was CH3 CH2 COOH. The third higher C2H5. How will it be C and C2H5? असंच लिहून दाखव ना मला. You just have to add CH2 to it, right, Sankalpa? Don't do it. Here already there are 3 carbon atoms. So your 3 carbon atoms, don't write the formula, just add CH2 to this, the third higher and the second lower. How can you do that? If you all have the book, don't look into the book. We are just trying to see if you can do it. I didn't get the question. C. Write down the structural formulae of the third higher. So this is third higher of this. So you have, supposing consider, so 3 more carbon atoms from this and the second lower homologue of this. That is, you have to remove the 2 carbon atom. So the structural formula of the third higher is obtained by adding 3 CH2 units. Okay, so can you show me that formula? Now we have gone to this, that is third higher, right? So how many CH2 units? You will have to add 3 CH2 units. So what will be the formula? This was it, right? CH3, CH2 and COH. But ह्याच्यामध्ये मध्ये okay, good. CH3, CH2, CH2 and yeah, you are adding, yeah. Now only Sankalpa is writing. What about the others? Are you with us? Yeah. May all the time Sankalpa answers. I think somebody left. कोणतरी निघाला and Suraj. Okay, what about Suraj? Are you following it? Are you there with us? Anyways. Okay, so have you understood? Okay, then Suraj, write down the next one what they have asked us. That second, एक minute. They have asked us about the second lower homologue. How will you put this? Second lower homologue. Second lower homologue. Lower म्हणजे आता मागे जायला पाहिजे. So if that is the case, then I think you will have to remove the 2 carbon atoms. So what will be the formula? Yes, पण COOH लिहिलंय बरोबर लिहिलंय, but you should be writing HCOOH. This is the first one. This is the formic acid. ह्याला म्हटलं जातं. So इथे H हवाय ह्याला पुढे. कारण बघ आता which one was my आपला त्याचा पहिलं the starting material was this, right? CH2 and COH. So they have told us to remove CH2. When you remove CH2, so what remains? It remains as HCOH, right? So you have to remove CH2 that way. Okay. So the number of CH2 to be added and the number of CH2 to be reduced. Fine. Let us go back and just check it. Okay. So here you are, the third higher homologue. So this was correct, which Sankalpa gave us. Sankalpa only, na? Yes. And next structural formula, the second lower is obtained by removing. So here you are. Then Suraj, you also gave right. Only thing is you did not put H because हे बघ ह्याच्यातनं CH2 काढल्यानंतर you are getting the here you are getting that CH. So always remember, and this is nothing but formic acid. Do you know where you get formic acid from? Any idea? How did it get the name formic acid? Kalpana आहे तुम्हाला? Formic acid is obtained from, it is a common name. It's the name of that is methanoic acid. Formic acid was obtained from red ants. आपल्याला लाल मुंगी चावली ना की जरा चुरचुरतं. So why is it? Because that formic acid, and that formic acid is from and from those red ants. Typical some variety of red ants आणि त्यांना त्याला फॉर्मिकस म्हटलंय. तर फॉर्मिकस मीन्स रेड ant आणि त्याच्यापासून आपल्याला मिळालंय म्हणून it was called as formic acid. सुरुवातीचं when they were all scientists were trying to give name to it, so it was formic. Then you also have acetic acid. Acetic acid is nothing but the next ethanoic acid. म्हणजे methanoic is first. HCOH ज्याला formic acid म्हणतात. Ethanoic acid म्हणजे तुमचं acetic acid. Acetic acid म्हणजे vinegar. Vinegar म्हणजे तुम्ही चिली वॉटर वगैरे चायनीज मध्ये घालता ना, that is called as it is a very mild acid dilute form of vinegar, acetic acid, which is used to make vinegar. And acetum is the name is from that vinegar, so acetic acid. तसंच butyric acid is obtained from rancid butter खराब झाल्यानंतर तो जो टिपिकल असतो म्हणून त्याला अशी ही जी नावं आहेत ते पूर्वीच्या काळी ना वेगवेगळे सायंटिस्ट म्हणजे they were also trying to find out and trying to give names, but when so many names started coming together, आता methane, ethane, propane, it is obtained from marshy land. The gas is obtained from marshy land, so the name was given as methane, ethane, propane. Okay, and which means the same thing, that the gas obtained. So ashi survatila they started giving name, but later on they came to know that we need to give some proper names. Like, okay, some scientists from India is giving some names, some scientists from Russia is giving, so Latin, German scientists, then you have Latin names, you have Greek names. So ashi ji nawa yala lagli. So then they started that we should have a common body which will be giving it. And so then the names were started being given by a common, that is International Union of Pure and Applied Chemistry. So those names which are given by that is called as IUPAC nomenclature, IUPAC nomenclature. आणि मग त्याच्यापासून ही वेगवेगळी नावं म्हणजे ठरली गेली आणि एनी कंपाऊंड नीड्स टू बी रजिस्टर्ड अंडर दॅट व्हेन अ न्यू कंपाऊंड इज. आता मध्ये आज हल्लीच द last elements in the periodic table, they have been the newly discovered elements, that is the last row, that is the 7th row in the periodic table, was incomplete so far. Now we have 118 elements. तर त्यांना पण नावं दिली गेली जात आहेत. So there is a body which decides the name, you know. So when a new compound is formed, isolated or found out, that time they give these names, and those names are given by the International Union of Pure and Applied Chemistry. We'll see about that and its nomenclature. But आतापर्यंत कळलं तुम्हाला? Yes, we will study IUPAC later. Yes, Suraj, correct. We'll be studying that IUPAC names. You must have done it in your earlier standard, at least तुम्हाला त्याचा एक थोडंसं त्याच्याबद्दल माहिती असेल गेलेली. Yes, done, correct. So that is how this chemistry, I mean, right now we are just taking a brief history की कुठून सुरुवात झाली किंवा हाऊ डू यू रिप्रेझेंट अ स्ट्रक्चर. आफ्टर रिप्रेझेंटिंग द स्ट्रक्चर, व्हॉट इज अ फॅमिली, व्हॉट इज अ फंक्शनल ग्रुप, व्हॉट इज अ होमोलॉगस सिरीज, हे सगळं आपण बघितलं. आता ह्याच्या पुढे आपण नावं त्यांची हे घेणार आहोत. सो इज इट क्लिअर सो फार? इट इज नाव आवर क्लास टायमिंग इज ओव्हर. सो वी विल मीट नेक्स्ट Friday. Today is Saturday, na? Okay. So till then, bye bye. I think yes. Today I know homework. What homework? Do you all need any homework? Homework? What homework will you do? Can you give me the names of um, first five? Mm, which have you done? Are you aware of aldehyde? Yeah, you put in the names of first five alkenes, that is the homologs. First five, put in first seven alkenes. Straight, okay, fine. Straight chain, no branching. And uh, let the double bond be at the end. म्हणजे एकाच ठिकाणी मध्ये कुठेही don't change the double bond. Then you will have that is इथीन, प्रोपीन, ब्युटीन. मग ब्युटीन मध्ये तुम्हाला वेगवेगळे त्याचे हे मिळतील. 2 butene, 1 butene. So only keep the double bond or first carbon atom only. Like that, you just give me. Yeah, I'll post it in the classroom. I post it in the classroom, but you people don't do the homework. So only I think a few people do the homework. Anyways, huh? Please, I'll post it in the classroom. Don't worry about that. Fine. Okay. Thank you. Good night. Take care. So I'm ending the class.